Hello, welcome to Engineer's Mindset. So let's say we're doing this problem z equals x squared y plus xy, and we're asked to find partial derivative of z with respect to x and partial derivative of z with respect to y from first principle. So let's say z equals x squared y plus xy. Okay, so to find the partial derivative of z with respect to x, alright, so I said in the first video, a little increase in the value of z will cause a corresponding increase in the value of x. So if I'm looking for partial z, partial x, it means I'm going to treat y and y as constants. Okay, so that will give me z plus change in z is now equal to, since z has increased by change in z, it means x will also increase in value by change in x. So I'll have, in place of this x, I'll have x plus change in x. But remember, this x is actually squared. So I'm going to have all squared times y. Y is kept as constant because the partial derivative is with respect to z, to m and x. Okay, so I'll have plus x also will increase x by changing x, okay, multiplied by y. So I have this. Okay, so z plus change in z is now equal to, if I expand this bracket, x plus change in x all squared, I'm going to have x squared plus 2x change in x plus change in x all squared, okay, multiplied by y, okay, multiplied by y plus x plus change in x multiplied by y. Alright. So I'm going to have z plus change in z is equal to, if I expand this bracket, y multiplied by x squared will give me x squared y multiplied by 2x change in x will give me plus 2xy change in x plus y multiplied by change in x squared will give me y change in x all squared plus, if I also expand this bracket, I'm going to have y multiplied by x will give me x, y multiplied by change in x will give me plus y change in x. Okay, so I have this. Now let me transfer z over to this side of the equation. If I transfer z over to this side of the equation, I'm going to have change in z left here. So change in z is now equal to x squared y plus 2xy change in x plus y change in x squared plus x y plus y change in x minus z. Okay, so I have this equation here. Alright, so at this point, recall that z itself from the question was given as x squared y, which is here, plus xy. Okay, so in place of z at this point, we'll simply put in the value as this. So we are going to have this equation to be, okay, so we are going to have this to be okay, so we're going to have that change in z is equal to x squared y plus 2x y change in x plus y change in x squared plus xy plus y change in x, then in place of z, we are simply going to have minus z is actually x squared y plus x y. So that's what we have. Okay, so we'll now expand and see change in z is equal to x squared y plus 2xy change in x plus y change in x squared plus x y plus y change in x. If I expand this bracket, minus multiplies x squared y gives me minus x squared y plus minus multiplies xy gives me minus xy. At this point, you pause. Notice that you have x squared y and you have minus x squared y. Also, you have xy minus xy. So it means that x squared y can strike minus x squared y. And also, xy can strike xy. So what we have left is change in z equal to 2x y change in x plus y change in x squared. Okay, that's all. Plus y change in x. Okay, we still have plus y change in x. So that's all we have. At this point, divide both sides by change in x. So you're going to have change in z all over change in x is equal to, this is 2x y change in x plus y change in x squared plus y change in x all divided by change in x. And you can as well write this equation to be change in z over change in x equal to, this equation can be written as 2x y change in x divided by change in x plus y change in x squared divided by change in x plus y change in x divided by change in x. So at this point, notice that change in x will divide change in s. Change in x here will cancel one of these change in x, and then change in x here will strike change in x. So it means you have that change in z over change in x is now equal to, you are left with, this is 2xy plus y change in x plus y. Okay, now at this point, take your limit. The limit as change in x tends to 0, the function change in z over change in x actually tends to partial c with respect to partial x. Okay, so that simply implies that wherever I see change in x, I should put in the value as 0. Once that law is held, then this function change in z with respect to change in x will automatically become partial derivative of z with respect to x. Okay, so therefore, this now implies that partial z, partial x is now equal to, we have 2xy plus y. In place of change in x, we simply substitute the value as 0. So you have y times 0 plus y. Okay, so at this point, y times 0 is cancelled. So therefore, you have that the partial derivative of z with respect to x is simply 2xy plus y. So this happens to be the answer to that partial derivative. Alright, so we'll do the second part. Okay, so in case it's not clear, let me bring it up here a bit. Okay, so partial derivative of z with respect to x is simply 2xy plus y. So that's the partial derivative. So that's the first part. The second part says we should find the partial derivative of z with respect to y, also from first principle. So let's do the second part of the question. Okay, so the second part of the question says we should find the partial derivative of z with respect to y. So the question is z equals to x squared y plus xy. So we have to find partial z, partial y. So in this case, z is changing with respect to y. So that means that x is kept as constant. And if x is kept constant, it means as z changes, y will change. Okay, so a little increase in the value of z plus change in z will also cause a corresponding increase now in the value of y, keeping x as constant. So I'll have x squared kept constant. Okay, so y changes by change in y. Okay, plus x is kept constant, then y increases by change in y. So I have this z plus change in z is equal to, now we expand the bracket, x squared multiplied by y gives us x squared y plus x squared multiplied by change in y gives us x squared change in y plus x multiplied by y gives us x y plus x multiplied change in y gives us s change in y. Okay, so at this point, let me send z over to this side of the equation, keeping change in z at this point. So I have change in z to be equal to x squared y plus x squared change in y plus x y plus x change in y minus z. Okay, so if I have that, but recall, okay, that z is equal to x squared y plus x y from the question. Okay, so in place of z, I simply put in the value as this. I'm going to have that change in z is equal to x squared y plus x squared change in y plus x y plus x change in y minus, in place of z, I simply have x squared y plus x y. Close your brackets. Okay. Alright, so at this point, I will expand the bracket. So I have that change in z equals x squared y plus x squared change in y, x squared change in y plus xy plus x change in y. So if I expand this bracket, minus multiplies x squared y gives me minus x squared y. Also, minus multiplies xy gives me minus xy. So at this point, you pause. You have x squared y minus x squared y, so they can strike. You also have xy minus xy, so they can strike. So you're left with change in z equal to x squared change in y plus x change in y. Okay, so this is what you have. Alright, so divide both sides by change in y. So you have change in z divided by change in y, and that's equal to x squared change in y plus x change in y all over change in y. And I said this equation can also be broken as saying change in z over change in y can be equal to x squared change in y divided by change in y plus x change in y divided by change in y. So at this point, change in y can strike change in y, change in y can strike change in y. You have that change in z divides change in y equal to, this is x squared plus x, and limit as change in y tends to 0, the function change in z divides change in y actually tends to partial derivative of z with respect to y. Okay, so at this point, there is no change in y to replace as 0. So that simply means that the partial derivative of z with respect to y is simply x squared plus x. Alright guys, that's it from first principle of partial derivative. I will see you in the next video with another wonderful question on first principle. Don't forget to subscribe to the channel if you're new, and of course like, share, and I would like to hear your comments in the comment section. Thanks and cheers.